Hi guys, welcome to Trig. I'm Miss Igo and we're going to start this course by talking about section 1.1, which is angles. As we start talking about angles, the first thing we need to do is to discuss some vocabulary. Some basic terminology when talking about angles. In this diagram here, we have an initial side and a terminal side, and the point where they meet is called a vertex. The initial side is always going to be parallel with the x-axis, and the terminal side is going to change depending on what the angle is. Now we can have different types of angles. A positive angle is an angle that's formed by a counterclockwise rotation of the terminal ray. So here is our initial side, and then if we rotate counterclockwise, we're going to have a positive angle. If we start with our initial side and we rotate clockwise, then that will be a negative angle. The most common measurement in an angle is a unit called degrees. The Babylonians assigned 360 degrees to one complete rotation of the terminal ray. So if we go all the way around, that's 360 degrees. The different types of angles are as we see here. We have an acute angle, which is any angle that is between 0 and 90 degrees. An obtuse angle is any angle that's between 90 and 180 degrees. A straight angle is just like it says, it's a straight line, and that would measure 180 degrees. That's halfway around the circle. Half of 360 is 180. And then we have a right angle, which has a measure of 90 degrees. Complementary angles are two angles whose sum is 90 degrees. This would be an example of complementary angles. Supplementary angles are two angles whose sum is 180 degrees. All right, so in example 1, it says to find the measure of each marked angle in the above figures A and B. Okay, so in A, if we wanted to find the measure of the two angles, we can set up an expression or an equation because of the fact that we know that since they're complementary, they add up to be 90 degrees. So we could set this up as 6x plus 3x equals 90, or 90 degrees. All right, and then we can combine our like terms. 6x plus 3x, that's 9x. And then we would divide by 9. And that would give us that x equals 10 degrees. Now that's x, that doesn't answer the question. We're supposed to find each marked angle. So this first angle, we would just replace x with 10, and we get 6 times 10, which would be 60 degrees. And then in the other angle, we have a 3 times x, so that would be 3 times 10. So that would give us 30 degrees. And of course, 60 plus 30 does equal 90. Now in B, these two angles are supplementary. And we know that if they're supplementary, they have to add to be 180 degrees. So we're going to set up an equation just like we did in the other one, except for in this one, when we add the two angles together, we're going to have them equal 180 degrees instead of 90. So if I add 4x plus 6x, that's 10x equals 180. Divide by 10, and x equals 18. Okay, so that's 18 degrees. So we're going to do the same thing, and we are going to plug x into each angle. So we have 4 times, or not plug x in, plug 18 in for x. All right, so 4 times 18 would give us 72 degrees for this first angle, and then 6 times 18 would give us an angle of 108 degrees. And again, 72 plus 108 does equal 180. Sorry about that. Okay, the complement and the supplement of an angle measuring 40 degrees. Okay, so we know that if two angles are complementary, they add up to be what? 90 degrees. So the complement of an angle measuring 40 degrees would be, we don't know what it is, but we know that if we add it to the 40 degrees, those two together would equal 90 degrees. So all I have to do is subtract 40 from 90 degrees, and that would give me 50 degrees. So the complement of an angle measuring 40 degrees would be 50 degrees. And then an angle that's supplementary to an angle measuring 40 degrees, we know that if they're supplements, they add up to be 180 degrees. So I'm just going to subtract 40 from 180 to figure out what the supplement of an angle measuring 40 degrees is, and that would be 140 degrees. If you wanted to set it up like an equation, we don't know what the angle is, but we know it plus 40 degrees equals 180, and then I would subtract 40 from both sides. So I would get that x is 140 degrees. A portion of a degree is measured in minutes and seconds. 1 minute, written like this, where we have the little apostrophe beside the 1, is 1/60th of a degree. So 60 minutes, or 60 with the little mark through it, which means minutes, equals 1 degree. A second is written as 1 with the little part of a quotation by it, the little 2 apostrophes or a quotation. That stands for 1 3,600ths of a degree, or 3600ths of a degree. So 60 seconds equals 1 minute. So 60 seconds equals 1 minute, and then 60 minutes equals 1 degree. So we can get a more accurate measure of an angle when it's given in degree, minute, second form. For example, instead of just rounding this to 34 degrees, this would be 34 degrees, 16 minutes, 57 seconds. Okay, we're going to perform each calculation by hand, and we do that by adding the like terms. So I'm going to stack these on top of each other. We are adding these, so I'm just going to match up the different parts of the angle. 1 second, let's see. Okay, so we have 55 degrees, 4 minutes, 17 seconds. All right, so the difference is when we add these, usually if we're adding decimals, we're going to carry it once we get to a 10. But since we're adding degrees, minutes, seconds, every 60 seconds gives me 1 minute, every 60 minutes gives me 1 degree. So we're going to carry it once we get to 60. Okay, but so if we add these together, if we add the 45 and the 17, I get 62 seconds. Okay, I'll carry it in just a minute. All right, and then this would give me, if I add 58 plus 4, that says 62 minutes. And then if I add these together, I get 162 degrees. Okay, but since 60 of those seconds actually gives me another minute, I need to carry that over. Okay, so this 6 is actually going to carry over to the minutes, and now I only have 2 seconds, and then that gives me 63 minutes. But again, I need to carry that 6 over, and that gives me 163 degrees. Okay, so let me just rewrite that. That's 163 degrees, 3 minutes, and 2 seconds. All right, we're going to do that again with B, but this time we're subtracting. So I'm going to subtract 36 degrees 5 minutes from 80 degrees. But just like if we were doing this with decimals, we can't subtract this 5 minutes from 0. If I were to write this as 80 degrees and 0 minutes, I can't subtract 5 from 0 minutes. So I'm going to have to borrow 1 from the 80 degrees, and I'm going to change this to 79 degrees and 60 minutes. And I'm going to subtract the 36 degrees 5 minutes. All right, so if I subtract 5 minutes from 60 minutes, then that gives me 55 minutes. And then I'm going to subtract the 36 from 79, and I get 43 degrees. All right, so that's 43 degrees, 55 minutes. We can also convert from degrees to degree minute seconds and vice versa. So we're going to convert this degree minute seconds to decimal degrees to the nearest thousandth. And the way that we do that is we take each either the degree minute seconds, and we're going to have to divide. So we're going to take this 14, and that will be divided by, so remember seconds, it takes 60 seconds to make 1 minute and 60 minutes to make a degree. So really this is 60 times 60. So we're dividing the seconds by 3,600, which goes back to what we said in the notes back up here. Oh, that's too far. That a second is 3,600 of a degree, or 3,600ths of a degree. Okay, so that's what we're going to do, is we're going to divide the, seconds by 3,600, and then we'll divide the minutes by 60. Okay, so if I divide the seconds by 3,600, and it says to round to the nearest thousandth. Well, if I divide this, I get 0.00, and then it's 39, so that would be 0.04 for the seconds. Okay, and then for the minutes, when I divide by 60, I get 0.1333. So I'm doing it again to the nearest thousandths place. And then this, I'll just bring down the 74. And then I just add all those together. So that would give me, in decimal degrees, 74.137 degrees, or 74 and 137 thousandths of a degree. Okay, so now we're going to go the other way. So to get from degrees, minutes, seconds to decimal degrees, we divided. To get from decimal degrees to degree, minutes, seconds, we're going to multiply. So what we do is we take the decimal part of the degrees, and we multiply this times 60. Okay, so we have the 34 plus this 817 thousandths times 60. Okay, so that's going to give me 34, and then that when I multiply that, I get 49.02 or 2/100 minutes. Okay, then I take the decimal on that and I'm going to multiply it times 60. All right, so this would equal 34 plus 49 plus, I take that 2/100 and multiply it times 60. And when I do that, I get 1.2. Okay, so I have the 34 plus the 49 plus 1.2, and I just add those together. And I would get 34, well, this was minutes, and this is degrees. So 34 degrees, 49 minutes, and then we never, if there's a decimal on our seconds, we just round that. Okay, so then it would be 1 second. And that's how we change from decimal degrees to degree minute seconds. Now, there is also a way to convert it in your calculator. All right, so if you to convert it in your calculator, if you have the TI-36X Pro, if you press the math button, there are categories at the top that say math, number, DMS, which is degree minute seconds. So if you scroll over to degree minute seconds, number 1 is the degree, number 2 is the minute, and number 3 is the second. So you can use your calculator to do that, but you will also need to be able to convert it by hand. All right, angles in standard position. An angle with its vertex point at the origin and its initial side along the positive x-axis is said to be drawn in standard position. So the way that we talked about it at the very beginning, when we have the initial side on the x-axis, it's got to be on the positive x-axis, just like this, and then the terminal side is connected to that by the vertex. That's considered to be in standard position. So we have, we know that the different quadrants, whenever we are in standard position, if it's between 0 and 90 degrees, that's going to be considered to be in quadrant 1. If it's between 90 and 180 degrees, that's quadrant 2. Quadrant 3 is between 180 and 270, and quadrant 4 is between 270 and 360 degrees. All right, so now we're going to draw each angle in standard position. So just remember that if we have an angle in standard position, we know that the initial side is going to be, and my lines are not going to be perfect, but we'll imagine that that is parallel to the x-axis. Okay, so then 30 degrees, remember if it's a positive angle, it's got to be traveling in the counterclockwise direction. Okay, so 30 degrees, thought that was the eraser. Okay, so 30 degrees is, we know straight up is 90 degrees. If half of that would be 45 degrees, so 30 degrees would be about in here. And then always when we're drawing our angles, we have to show what direction it's traveling. Because, for example, if we traveled this direction, then that would be a negative angle. And of course, it would be a lot bigger than 30 degrees. It would be 330 degrees. So we have to put in our direction of travel for our angle. Okay, so that would be an angle in standard position that measures 30 degrees. Okay, so for 140 degrees, again, we draw our initial side. Let me try to make that a little better. Okay, this is our initial side. Now remember, again, straight up would be 90. A straight angle, that would be 180 degrees. So we would say 140 would be somewhere in here. and that's if we travel this direction. 330 degrees. Well, we know if we travel all the way around, that's 360, so we need to back up a little bit and say about in here. And we need to show that we traveled this direction for 330 degrees. Here we have a negative angle. It's a negative 45 degrees, so we know that we're going to be traveling in the clockwise direction. We start again with our initial side, and this time instead of going this direction, we're going to go this direction. 45 degrees would be halfway to our 270 mark. So, and we're traveling in the clockwise direction, so that would be a negative 45 degrees. Okay, 800 degrees would be if we were to travel around our circle. We'd have, well, if we travel, first of all, let's write our initial side. Now, if we travel around our circle one rotation, that's 360 degrees. Okay, if we travel around it another rotation, that would be 720 degrees. All right, and then if we need to get to 800, we know that that's 80 more degrees, 80 degrees more than 2 rotations around the circle. So our line would end up being about right here, so it's not quite 90, but we went around the circle twice, and then we ended up at this terminal side. Okay, and then a negative 1010. Let's draw our initial side again first. And we know if it's negative, we're going to go in the clockwise direction. Okay, so if we start here and we go clockwise one time, that's a negative 360. If we go clockwise again, that would be a negative 720. If we go clockwise all the way again, then that would be a negative 1080. Okay, so we don't want to go all the way back around. We would go, so if all the way around again was 1080, we need to back up 70 degrees. So we would be right in here. Let's see. And that would be our negative 1010. But always draw the direction that your terminal side is traveling. Angles in standard position whose terminal sides lie on the X or Y axis, such as angles with measures of 90, 180, 270, 360, and we could keep going all the way around the circle several times. But if our terminal side ends on one of those marks, then it's called a quadrantal angle. Two angles that are drawn in standard position that share the same terminal ray are called coterminal angles. Their measures differ by multiples of 360 degrees. So an example of coterminal angles are 30 degrees and 390 degrees because they differ by 360 degrees. Just like these examples that we showed you here, or that we did here, we went around the circle several times, so each time we go around, those are coterminal angles. Okay, so to find an angle of least positive measure that's coterminal with each angle, they mean the smallest angle that would land in that same spot. All we have to do, if it's a big number like this, we're going to just start subtracting 360 degrees. So if I subtract 360 degrees from 908, that gives me 548. Okay, so they want it to be the least positive measure. Okay, so we know that's not the least positive measure because the least positive measure is going to have to be something between 0 and 360 degrees. So let's subtract 360 again. All right, so if I subtract 360 again, I get 188. So that would be the angle of least positive measure that's coterminal with 908 degrees. Okay, so for B, we have a negative angle. So to get the least positive, we're going to have to add 360 degrees. So if I add 360 degrees to a negative 75, I get 285 degrees. Okay, for negative 180, again, we're wanting a positive angle, so I'm going to add 360. I know that's not going to be enough, so let me go ahead and add 720. That's still not going to be enough. So that would give me a negative 80 degrees. So one more time, let me add 360. And that would give me 280 degrees. And that would be the least positive measure that's coterminal with the angle. All right, here we have a degree and with minutes. All we have to do is add 360 degrees. If I add 360 degrees, that 40 minutes is just going to carry. Oh, I'm sorry, not add 360 degrees. I need, the least positive measure that's coterminal with this angle. I'm going to add 360 degrees, and that's 386 degrees. Okay, so 386 degrees, 40 minutes, even though that's not in the circle between 0 and 360, this would be the smallest one. So the very next smallest angle that's coterminal with this angle, if we go one rotation around, would be 360 degrees, 40 minutes. And that's our lesson on angles.